Hey guys, I am here to teach you a lesson today, section 1.1 of the book, Unit 3, Day 1, Solving Linear and Literal Equations. So a couple of things about solving linear equations. This is something you did in Algebra 1. There's three types of solutions that you could possibly get to a linear equation, or really any equation. Okay, the first kind is called an identity. Now, you do not need to memorize these names, but this is the technical name. An identity equation is when the left side is exactly equal to the right side. So in this example, obviously 3x plus 15 is equal to, if I distribute, I also get 3x plus 15. So this is the exact same thing on the left as it is on the right. And in this situation, your solution will end up being infinitely many solutions. Some people's teachers in Algebra 1 call it all real numbers. Some teachers do this fancy R, which stands for real numbers. And all of those are acceptable answers, okay? I like IMS for infinitely many solutions. But essentially, any value I plug in for the letter x will come to be a true solution or a true statement because I have the same thing on the left as I do the right. The second and most common type of equation is going to be a conditional equation. This is when you get one singular answer. One singular answer for a linear equation. I should say one solution, but one answer is fine. And so that's why it's called conditional. If I solve this equation and divide by 3, I get x equals 7. So what that literally means is if x equals 7, then the equation is true. That's, you guys remember conditional statements from geometry, if then. If x is 7, then the statement is true. So that's called a conditional equation when you get one answer. Finally, we get a contradiction. A contradiction is when I have my variables drop out, but then I get a false statement. So in this situation, if I subtract over an x, it cancels on both sides, and I'm left with 0 equals negative 21, which is a false statement. 0 does not equal negative 21. So in this situation, there is no solution. Okay, so you can write out no solution. You can do a circle with a line through it. Guys, not just a circle. Just a circle, I think the answer is 0, so that's not right. Or my personal favorite, it's a no-so. I've tried to make that happen every year. Not sure if it ever stuck, but it is a no-so. All right, so those are the three types of equations that you may come across while solving linear equations. So now I'm going to get into some more complicated types of equations. Starting with number 1, let's just go ahead and solve. We're going to distribute the 3. We get a 6x minus 12 equals 7 minus, I'm going to distribute my negative 2. Distribute the negative with the 2. So it's minus a 2x, and then it's a plus 10, because the negative goes to both of the things in the parentheses. So then I have, let's combine like terms on the right. So 6x minus 12 is equal to 7 and 10 combines to 17. So negative 2x plus 17. And you guys know how to solve from here. I'm going to add 2x to the left. And since we're in Algebra 2, I'm going to do it this way. I'm going to simultaneously add 12 to the right. All right, I get an 8x equals 17 and 12 is 29. And divide both sides by 8. Now, maybe your anxiety level went up when you saw that it's not going to be a nice answer, but welcome to Algebra 2. We don't always get nice answers. That's okay. All right. So that's the deal with your typical equation for linear. But let's get into something a little more challenging, like number 2. Oh my goodness, I see fractions and I'm afraid. That's kind of the response I get from you guys a lot of the time when you see fractions. But there is a trick, and the trick is that you can clear out these fractions by doing one simple step. So if you look at all of the fractions, you can get a common denominator of those numbers. So the common denominator, the LCD, of 3 and 6 is 6. So if you actually multiply both sides, you got to do it to both sides, by 6, you will clear out the fractions. So distribute it. So 5 over 6 times 6, the 6's cancel, and you just get a 5x. Oops. 6, you got to multiply it to everything. So 6 times negative 2 is minus 12x. And then 6 times a third is going to be 6 divided by 3 is 2 times 1 is 2. So plus 2. Equals, and here the 6 and the 3 reduce to 2 over 1, so I get 2 times 2, which is 4. The trick I use is I divide the number, I divide it by the bottom, and then I multiply it by the top. So 6 divided by 3 is 2, times 2 is 4. All right, now we just finished solving. 5x minus 12x is negative 7x. And then, you know what? I'm going to take a shortcut, subtract the 2. So equals 2, and divide over the negative 7, so x equals 2 over negative 7, or negative 2/7. Beautiful. Moving on. All right, same kind of idea with the decimals. I can clear out, these are all to the 10th place, sorry. So if it's to the 10th place, which is only one decimal spot, what I can do is multiply both sides by the number 10. Okay, so multiplying by 10 is actually going to move the decimal over one spot. Now, if there was 2 decimal spots instead of 1, if it was like 0.35 and 0.55, then you could multiply by 100 to move the decimal over 2 spots. So the number of zeros after 1 and the number you multiply will move the decimal that many spots. Okay, so this is going to be a 3 parentheses x plus 2. So I'm only distributing to these numbers. Okay, I don't have to distribute into the parentheses as well. That would be over distributing. And the reason is because I am still going to distribute this 3 in. Okay, so then I would be doing it too much if I double did it. Double dipped. All right, so we got a 5 parentheses x plus 2 equals negative 2 minus 4. So all I did was move my decimals over one spot, and now I can just solve this equation normally. So I'm going to distribute my 3x plus 6, distribute the negative with the 5, minus 5x minus 10 equals negative 6, combining. So combining my x's, I'm going to get a negative 2x minus 4 equals negative 6. And I'm going to add over a 4. So I get negative 2x equals negative 2, so x is 1. Divide over the negative 2, we get x is 1. Ta-da! A nice answer. And finally, number 4. Let's see, I'm going to combine like terms on the right side. So 7x minus 4 on the left equals 7x. Now, the 7x is going to cancel out on both sides. If I subtract a 7x over, it cancels out, and I get negative 4 equals nothing, or 0, which is a no solution, because negative 4 does not equal 0. So this is, a no-so, or a no solution. Okay? Those are all linear equations, all right? And then I have something called literal equations for the second half of our notes. Literal equations have more than one variable in it when you're solving for a variable. So your answer will not be like one numerical answer. It'll have several parts to it. So when it says solve for t, it means I want to get t by itself. So if I look at my equation, I'm trying to get this t by itself. I'm going to follow all the normal equation rules. So I am eventually going to divide by this a. But if this was like a 2, plus 5x, what would I do first? Well, I would have to get just the 5x by itself. I would have to subtract over the 2. Well, I'm going to do the same thing here. I'm going to subtract over this. Now, this is kind of weird looking, right? That's a v with a subscript of 0. We call that in math a v naught, and it does not combine with a regular v. It's like having an exponent on it, like v squared, which would not combine with like a regular v. So it looks like this. I get a regular v minus the v naught equals a times t. And if I'm trying to get the t by itself, now I can divide the a. When you divide the a, you divide the entire other side by a, and that's your answer. I'm going to write it like this. T equals v minus v naught all over a. So I still use the same rules of solving equations, but it's not a simple numerical answer because there's several variables going on. Okay, the next one says solve for v naught. So now I'm trying to get this guy by itself. Ooh, there's a lot to do. The first thing I want to do is move this over to the left and this over to the left. So to move things to the left or to the right, I have to add or subtract. So I'm going to subtract over the 1/2 at squared. I'm also going to subtract over the x naught, the x sub 0, which will not combine with the regular x. So it's going to look like this. This original x minus 1/2 at squared minus x naught equals v naught times t. And now I'm going to divide everything by t. So I could clean this up, like this 1/2, technically that 2 could go on the bottom and the 1 could stay on the top, but I'm not going to be too picky about that. This is all over t equals v naught. So I'm accepting of this answer. Another way to write it would be x minus at squared minus x naught all over 2t. Because since that's in the denominator, you can rewrite it so that it goes in the denominator. Can you? No, you can't. You know what? I take that back. Shoot. I'm going to cut this out of the video. I would just leave it like this. Okay, so let's move on to number 7. 7 gets a little more complicated, guys, because it says solve for x. Well, there's 2 different x's. And I would try to combine like terms, but this a squared is going to make it more complicated. Okay, so let's go ahead. The strategy here is to get the x's on the same side to start. So I'm going to add this negative 3x. I'm going to add it to the left. It looks like this. A squared x plus 3x equals 2a squared. Now I cannot combine these. However, since they both have an x, what I can do is factor out the x. And I'm left with an a squared plus 3. And then it equals 2a squared. And now to get the x totally alone, I simply have to divide over this entire quantity. Okay, so divide it over to the right side, and my answer looks like this. 2a squared all over a squared plus 3. And I could put parentheses around that, but I don't really need it. Those a squareds don't cancel because on the bottom, the a squared is part of a binomial. Okay, so I'm done. All right, and one more problem like that just gets a little bit more complicated. This one says solve for x. Okay, this one's tough. So what I'm going to do is, the first thing I'm going to do is try to get this first x by itself by multiplying over the a minus 1. But when I do that, I have to FOIL. Oof. I'm left with an x on the left side. When I FOIL this out, I get a squared x minus ax plus 3a minus 3. So now I'm going to get all the x's to the left side. So I have the original x. I'm going to subtract over the a squared x, and I'm going to add over the ax. Okay, so I'm not showing like all these little steps, but hopefully you guys understand what I'm doing. All right, and then I'm left with a 3a minus 3 on the other side. So since all of these terms have an x, I can factor out an x. I'm left with a 1 minus a squared plus a equals 3a minus 3. Divide over this whole thing, 1 minus a squared plus a. And I'm left with x equals 3a minus 3 all over 1 minus a squared plus a. Now, I'm going to check to see if anything simplifies here, okay? I have a suspicion that it might, so let's see. On top, I can pull out a 3, and then I'm left with an a minus 1. On the bottom, if I rearrange this to negative a squared plus a plus 1, and pull out a negative, I'm left with an a squared minus a minus 1. Does that factor? Okay, it does not factor because of this minus a. So it's always, always, always worth it to check to see if it factors, but since it doesn't, I could have stopped right here. So I don't have to keep going, okay? There's some practice problems for you to try. And I will definitely go over all of this with you guys, but it's good for you just to get the video while you're waiting for class to start because we had to take the pre-test today. All right, guys, that's all. Have a good one.